Hello, and welcome to another SolidWorks how-to video. This time we're going to talk about the sweep feature. And to do that, we're going to have to get into a little bit of both reference geometry and 3D sketching. And we'll deal with those sort of when we get to them. But first, we'll do sort of a basic sweep. And to do that, we're going to start by creating a new part. And the part we're actually going to create in this video is a part that I created for a customer a while ago. And it looks like this. It's a little spring that's used in a small electric actuator. Just a little, sort of torsion bar spring, right, where it gets pressed on and springs back. It is tiny. You can see the wire diameter there is 28 thousandths of an inch, way over here. And if you look at the one-to-one scale on a sheet of paper, or at least in the PDF, which doesn't always represent one-to-one, it's a lot tinier than we've drawn it, right? So this is a tiny wire, but this is a good example of how to use a sweep in SolidWorks. So where do we begin? Well, just like with most of our other features, we're going to start with a sketch. So I'm going to come here into my SolidWorks, and on the top plane, I'm going to just create a sketch. And I'm going to reference back and forth to this window a lot. Now, for this particular model, I think the best place to start would be at this sort of top view here with the geometry to it. So the first thing to do is just sort of sketch in this rough shape. So I'm going to start with a line at the origin, and I know we come this way. If I look back, we have an arc. We go up straight for a bit. We have an arc, and we come down. So we want a center point arc. I'm sorry, a 3-point arc probably. So 1, 2, 3 points, and then back to our line, straight up. And again, at the sketching phase, we're being really rough. We're just getting the general shape correct. Another 3-point arc. This one comes all the way across. I'm going to let this one go ahead and snap its tangent relation in there because that's fine. I'm going to want it anyway. Now, this other leg dips down below that line, so we might as well draw it that way to begin with. We'll come down, we'll drop down below that original. We need another arc somewhere over this way, and a line finish us off. We'll make sure we get horizontal. We'll let the automatic horizontal constraint. Now we can start constraining these things and dropping dimensions in and getting accurate here. So first off, we need to constrain the rest of the tangency constraints. The top arc here has tangency constraints. This arc needs to be tangent here and tangent with the vertical. And we want to make sure to do the same thing with this arc because it's not quite, it looks like it, but if we zoom way in, we can see there's a bulge, and this one's shallow of the line. So we're not quite tangent on either end. We can fix that by applying our tangency constraint. Again, by control clicking the line in the arc, clicking tangent over in the feature tree. And those are all of our tangency constraints. So now dimensions. What do we have? 0 sort of is over here where I started at 0, 0. From there, the center of that first arc, let's zoom in to make it a little more readable, is 0.35 inches. So notice these are vertical because of our tangency constraint. The center and this, so it doesn't really matter which one we dimension here. I'm going to go ahead and dimension the point on the line back to 0, that is 0.35. And of course, again, SolidWorks automatically scales the rest of it because that was our first dimension, so that we stay in the ballpark. Now, that radius, what do we do about that radius? The thing to consider when duplicating parts a from a drawing, from an existing part, anything is how we are going to draw there, or how we're going to model, not draw. So this is drawn in such a way that it's buildable, right? If we were to bend this wire with tooling, I need to know this 0.36 radius because that's going to be the radius that I put on the tool that does the bending. However, this centered line is going to end up being sort of path that my sweep takes. So I'm going to pass along the center through this. The radius of that center is not 0.036. The radius of that center is going to be 0.036 plus half of the thickness of the wire, which is, if I scroll way down, find it, 0.028. So half of that, 0.014, plus this will give us the radius I want to define here. And I can either do that math, so I can select the curve, and that should be 0.05, if I did my math in my head correctly. So I can either do that math and ahead of time and type it directly in, or I can select and modify this 0.036 plus. Remember, a dimension field can do math, and 0.028 divided by 2, it's the same dimension because apparently I did do my math in my head correctly. But either way, I can either do it ahead of time or I can put the math in here directly. So I've got the 50 thousandths radius there. Up at the top, we've got 0.86 and again 0.28 for the wire. So if I grab this as a radius dimension, 0.086 plus 0.028 divided by 2 should come out to 0.1. It does. Look at that. Now, that height is a 1/4 inch from 0. 0 is the center line of this first flat. So 0, a 1/4 inch up to the center of that arc. And notice that SolidWorks wants to do it at an angle because that's where my mouse is. All I have to do to fix that is drag my mouse either this way or this way. Now, when it comes time to define a length, or if I wanted to define a length rather, right now the length will be defined by this length of the leg and the radius. But if I wanted to define it, I can come up and down with my mouse too, and it'll make it a horizontal dimension. But I want vertical, and that's a 0.25, a 1/4 inch. Okay. Our next bend should have the same 50 thousandths radius. And height-wise, the center is 0.25 below 0. So we'll go here, and we'll go 0.025 below 0. And we've got it. I'm going to drag this out just for legibility. And that's okay. We can drag these dimensions wherever we want to make them readable. You know, these two we can get out of here, put them somewhere where we can actually see what's going on. Now, the only thing left undefined is the length of that last leg. Based on our drawing here, it's dimensioned from 0, and it's 1.55 from 0. So back to 0, all the way to this opposite point, 0.155. Ooh, I must have read that incorrectly. 1.55. 1.55. There we go. Easily fixed. Now we're all black. We're locked down. We can accept this sketch. All we've created so far is a sketch. So we have a sketch of what this wire is going to look like. At least most of it. We have this plane of the wire with the shape. Let's zoom back out so we can see both views. We have this plane of the wire with the shape drawn. Now, for demonstration purposes, I'm going to start out by just sweeping this shape. And we'll do that, and then we'll come back, and then we'll demonstrate sort of how to do a sketch that accounts for this this leg here. So to do a sweep, we need two things. We need a path, which we've defined now. This is the path our swept shape will follow. And we also need a profile for it to sweep along that path. So to create a profile, I need a plane that is on one of these points, the start or the end point, whichever way you want to look at it. We can sweep in either direction. But I'm going to start here since this is where I defined 0, 0. And if I select my right plane, because I drew that point on the origin, that point is also on the right plane, right? 0, 0 is where all of those planes intersect. So on my right plane, I can create a circle that represents the diameter of this wire, which is 0.028. So I'm going to sketch again on the right plane. And SolidWorks sometimes gets a little goofy. Notice that it flung me, so I'm looking at the opposite end from what I want, and that puts a lot of things in the way. And actually, even if I manually flip it around, right, there's a lot of points in the way. One of the cool features that we didn't talk about much is that I don't necessarily have to let SolidWorks force me into viewing it this way. I don't even really have to sketch straight on. So if I've got a lot of points like this in my way, I can leave this at an angle and still sketch on this plane because that's where I've defined the sketch. So if I grab a circle, just sort of randomly draw it and rotate around, it's still on that right plane. And if I grab another circle, right, just for demo, and I draw it way out in space somewhere and start to rotate, I'm still on that same plane because I'm in a sketch that is defined to be on that plane. So I can leave things at an angle. I can grab this circle, which is the one I want, and control click at 0 and make it coincident. And now all that's left is to define the diameter at 28 thousandths, 0.028. Right. And we've got our circle. So I'm going to accept that sketch. So now I have a circle, which is going to be called the profile. And then I have the path, the original sketch of the shape of the wire. Right. So now I can go back to features and I can click swept, boss, or base. It comes up, with the properties, and it's going to be a sketch profile or circular profile. Circular profile is a little different. A circular profile is more like an automatic, say, way to create a spring. So it's going to automatically sweep our part around an axis. We don't want that. We want to follow the path we drew. But the first thing that it wants in blue here under sketch profile is it wants the profile. So it wants the circle. And I'm going to select that circle. Notice it filled in here. Sketch 2 is the name of that sketch. And now it wants the path. And I can select the path. And notice the preview shows me that I now have a part, if I accept here, that follows the path that I drew. So that is about as simple as it gets for sweeping. Now, if we talk about how to add in that leg, right? Because this is a 3D part, it has a little leg down here. This leg in actual use gets soldered in place in a circuit board, so it sort of anchors the spring in place. Again, tiny little spring, but it gets anchored in place. So how do we deal with that? First, I'm going to go ahead and I'm going to delete this sweep. Now, if I delete the sweep at the top level over here in my feature manager, if I delete that sweep, first it's going to warn me. Yes, it'll leave the sketches behind, which is what I want. I want at least the path. The circle can go away because I'm not going to use it again. Fair? So the circle goes away. Now I need to create a path that incorporates this path and the leg. And the leg should be straight down in the negative Z direction from here, right? If I keep my dimensions accurate. But I also have another problem where I'm too long because I drew at 0, 0. Actually, am I too long? Is that a true statement? It's not, because I started at 0, 0. My circle is going to come straight up at 0, 0. So that'll be fine. But I need to create a sketch straight down from here. So I'm going to sketch on the right plane, align. And again, I can draw at any angle. So I'm going to reorient this so I can see the point I'm working with. I want to be coincident with 0. I'm going to come straight down. And I need to define a length from 0. But again, this is 80 thousandths from the bottom surface. 0 is the center line. So it's going to be 80 thousandths plus half of our wired thickness. So if I select, in this case, I want to select the top plane, not necessarily this line, because if I choose to delete this line, then it'll break my dimension. So I can select the top plane, even though I can't see it. I can select it by selecting it in the feature tree. So I can select it over here in the feature tree and then come down to my point, and that'll give me a height from the plane to the point, which double checking should have been 80 thousandths. 0.08 plus 0.028 divided by 2. Okay, somewhere in there. And again, SolidWorks rounds, to 2 decimal places by default. We can change that elsewhere in the system settings. But that'll give me a starting point. Now, if I want to now sweep along this, I have an issue. I've got 2 issues. One we will address in just a moment. The first issue, though, I have to create a profile to sweep in the first place. And I can't really do that. I don't have a thing to sketch on. If I try to create a sketch, just sketch my circle. It wants a plane to start on. If I make my tree over here in my sketch view bigger, right? I've got the top plane, but the top plane's way up there. I don't want it on the top plane. I want to start at this point and sweep up and then follow the original path. But I don't have a plane down there. So how can I deal with that? And the answer to that question is through reference geometry. So if I go over to features, way over toward the right is a reference geometry tool. If I click it, I get all kinds of options. I can create all kinds of options. Reference geometry works a lot like construction geometry in a sketch, except in this case, it's 3-dimensional. So I can create a plane that exists for no other reason than I need to make a sketch on it. Or I can create an axis that exists so that I can revolve something around it, right? I can create all kinds of references to give me sort of the geometry that I need, or at least give me an ability to follow SolidWorks' rules when I create things. In this case, the rule is I got to have a plane to sketch on. So I'm going to create a reference plane, right? The first reference, the second reference, and the third reference. Remember, we're dealing in 3D. Depending on how complicated the reference geometry is, we may only need 1 reference or 2 references, right? Sometimes if it's really complicated and we have angles and we need offsets and things, we need all 3. And it can be lines of my sketch. It can be existing planes. It can be points, off of these arcs. It can be just about anything. Edges of a solid model. That's sort of what they're showing over here in the properties window, that you can select edges of a part that already exists for reference. The reference can be just about anything. In this case, my first reference is going to be the top plane because what I need is parallel to the top plane. So I'm going to select the top plane. Notice that it offset it automatically by default 0.01 inches. I don't want that. That's not right. So I'm going to flip the offset so that I don't have to work in negatives. I'm going to flip it. It pops it down 0.1. 0.1 in this case is a little too long for where I want my circle to be. Remember, this point needs to be on that circle. So I can either select my second reference to be the point, or I can change this distance. In this case, I'm going to change the distance. It was double checking my drawing, 80 thousandths plus half. The distance is 0.08 plus 0.028 divided by 2. 9.4, that's good. I'm going to accept that. Now I have a plane, and by default, it's visible. If you don't want to be able to see it, just like with the original planes, you can always, on the feature manager over here on the left, right-click and hit the little hide button, and it won't show up. It can still show up as soon as I click on it and select it. However, either way is fine. I'm going to show it for now so that we can see what we're working on. Now that I have a plane, I can go back to sketch, and I can create my wire diameter. And I'm just going to start here with coincident, dimension that circle 0.028, and I'm going to accept. So now I've got the profile and I've got the path. Let's go ahead and sweep it. If I know I'm going to sweep, I know I need a profile and a path, I can pre-select them. I don't have to select them afterwards. I can select the circle, control-click the path, features, swept boss. And notice now that it only sweeps up. That's because these are 2 different sketches. If I control-click the next line, it won't actually let me do it. There's a reason for that. It knows that I can't actually make that turn. What will happen if SolidWorks tries to make that turn, it'll end up sort of cutting itself with our circle. We need a radius here in order to make that work. The problem with that, I'm going to cancel out of my sweep because we know it won't work. The problem with that is that because these are two one-dimensional sketches, I can't actually make that bend radius work in these two sketches. So in a case like this is where 3D sketching comes in. So I am going to go ahead and, well, I can leave this in actually as a reference. I'm going to leave this one in as a reference. I'm not necessarily going to use them, but I can use my 3D sketch and these, which are already defined, to constrain them. Now I could, and what I was going to do, since these videos are all stream of consciousness, I was going to delete them and recreate this geometry from scratch. I don't need to do that. I can just use these as a reference for my new 3D sketch. So I'm going to create a sketch. If I come over here to the sketch button and the drop down, the only other option I've got is 3D sketch. Right? I'm now in a 3D sketch. Notice it did not ask me to select a plane. That is because a 3D sketch can be anywhere. It's not necessarily planar. So to do this, I'm going to select a line. I'm going to start at the point we already have down here, which is our start. I'm going to come straight up and exit out. I'm black because I'm constrained along this line. I told it to be constrained along that line. I'm going to do the same thing for this first horizontal line here, straight along it. So it's orange, click, and I'm black. Now I can still change the length because I haven't defined that. But it is coincident at both ends with that first 2D sketch line. Now I can create my radius between these two and click. Now, okay, this one behaved. Occasionally what we'll find is that even though we drew between these, because it's 3D sketch, it could draw this arc really anywhere it wants. And let's see if I can make it break. Nope, it's going to behave pretty well. Maybe if I switch my view enough. There we go. My view was switched. Notice it drew that second arc way out in a random orientation, right? That is one of the dangers of 3D sketches. So I recommend orienting your model rather than trying to fix a feature like that arc that was way out on a random angle. Orient your model and your view here something close to what you're trying to do, and let SolidWorks, figure it out by default is the easiest way to do it, rather than trying to force that weird arc back into the plane we want it to be in. So from here, again, I need to apply my tangency constraints, control-click the line and the arc, tangent. From here, everything works exactly the same way as it did in a 2D sketch. I need to constrain things. So I've got tangency constraints on both ends of the arc now. I lost my sketch. There we go. It's not going anywhere. But I haven't defined my radius yet. The radius on that bend is really tight, 6 thousandths. But again, we're defining the center of our sweep. So 6 thousandths plus 14 is 20 thousandths, 0.02. Okay. I'm going to escape to get out of dimensioning, but I am not going to accept yet because I still have to effectively trace the rest of the sketch that I created. And again, I could have done this from scratch and just recreated this and redimensioned it. For the sake of time, and since it's already here and dimensioned properly, I'm just going to trace over it with the standard tools, and I'm still in a 3D sketch. So I can select an arc, the end point of the arc, the end point of the arc, and notice I'm not going to move my mouse, but notice it's going to draw that in a weird plane again. As soon as I click, it wants to draw it at all kinds of weird angles, but as soon as I select the existing arc, it's going to make it coincident. If I escape out and deselect it, you can see that it's black, it's redefined, it's in plane. So that's good. The cool part about sort of tracing is I can go through with a line tool. Now, again, line, same thing, weird planes, right? But as soon as I select the other end, I'm locked down to the existing line. So I'm going to go through, since I have lines, I can just hit enter and it selects the line tool again. And I'm going to select the endpoints of both lines, escape to get out, enter to get back into the line tool, select and select. And now my lines are defined, and I'm going to do the same thing for the arcs. Arc tool, endpoint, endpoint, arc, escape, enter, because that was the last tool that I used, endpoint, endpoint, arc, escape. Now we are blue. I do believe that blue is just a side effect of selecting things, because if we click, we can't actually move anything. See, it says it's fixed. So it's just a viewport thing, not necessarily that we're under constrained. Like I'm clicking and dragging, and the tooltip there is telling me I can't drag it, it's fixed. Which means even though we're blue, we are fully constrained. So should this pop up on, say, an exam where I'm telling you you're fully constrained, don't worry about it. It's a thing that happens sometimes. So I'm going to accept that sketch in the upper right. Notice it's all blue now. It's all one 3D sketch. So now I'm going to select my circle, which was sketch 4, and I'm going to control click my 3D sketch. That's my new path. I'm going to come up to features and swept boss, and notice my yellow preview now shows me the entire swept spring. So that is an easy way, right, to get our sweep in. Now I've got this, original construction sort of sketch still visible. I can hide those by selecting them both and clicking the hide button. I can also hide my plane by clicking the hide button. As soon as I select it, I can either right click it in the feature manager here, or I can just select the plane and a little pop up and hide. And there's my spring. Now, again, as always, the last step I recommend is applying a material. In this case, we were 360 brass. So apply a material, that would be a copper alloy, and we'll just select brass because this version of SolidWorks doesn't look like it has 360. We'll apply, close, and we now have a brass spring created with a combination of sweeping and 3D sketching.